Tilt-up is a method of construction whereby large concrete panels are cast on site and then raised into position with a crane. The building system, which was conceptualized in the early 1900s, is used throughout North America and across the globe. It is employed on virtually every building type, from distribution centers to schools, churches, libraries, retail centers, and office buildings. A tilt-up job site is a dynamic environment, often with multiple stages of construction happening simultaneously. Although they don't have to be, the tilt-up job site is often flat, with plenty of room to maneuver large pieces of heavy equipment. Still, many tilt-up projects are completed on sites with more complex topography and/or tight conditions. Prior to the start of construction, hours are spent on site layout plans and sequencing diagrams. This upfront effort and attention to detail ensures the smooth and efficient movement of the crane, eliminates costly and dangerous unknowns, and best prepares crews for a productive and safe job. Once the site has been prepared, workers begin to construct the casting surface for the panels. This surface could be the building slab itself, a temporary recyclable casting slab, or a combination of both. Attention to detail is important to make the casting surfaces as perfectly flat and void of imperfections as possible, as tilt-up panels mirror the casting surface. The growth of tilt-up construction is linked to many advancements in equipment technology, such as the laser screed, which greatly improves the quality of the casting slabs, thus improving the quality of tilt-up panels. Once the concrete has been allowed to set up, workers utilize ride-on trowels to give the surface a smooth, flat finish. With the casting surface prepared, tilt-up panels are next laid out on the new slab according to the plans using chalk lines. Lasers are again used to ensure the precise location and dimensions of the panels. There are a variety of products and accessories available for the forming of tilt-up panels, but the majority of projects utilize dimensional lumber. Boards are used to form the edges of panels, as well as any openings or special features. Forming for panels is often nailed into place. Depending on the finished floor treatment, forms set on the building slab are sometimes glued down to avoid slab damage. The vast majority of the time, panels are cast with the exterior face of the panel down. Any rustication or reveals designed into the exterior face of the panel are installed at this time. Structural embeds designed for this face of the panel are also installed. A wide variety of form liners and embedded products are available to create forms and textures on the face of the panels. This project features thin brick. Thin brick is real kiln-fired clay brick made to very tight tolerances for use in form liner systems. This system utilizes a single-use form liner to create the layout and mortar joint profile and secure the bricks. Workers lay out the form liner according to the design and place the bricks into the brick pockets. Specially sized and scored bricks are snapped to create half bricks where needed. When the concrete is cured, the chemical process that bonds the concrete together also bonds the brick to the concrete. In addition, a mechanical connection is created by the concrete interlocking with grooves on the back of the bricks, holding them securely in place on the building facade. When form liners or thin brick are not used, a release agent or bond breaker is then applied to the slab. This product reacts with the byproducts of the concrete hydration process to prevent sticking and allow panels to lift easily. A properly applied bond breaker will allow water to bead up on the slab, just like water on a wax-polished car. At this point in the process, workers install steel reinforcement in the panels. The steel sets on plastic chairs that hold the reinforcement in place and keep it from touching the slab. The bars cross each other and are tied together with wire or other accessories. Additional structural embeds that will later connect to floor or roof systems are also tied into the grid. Lifting and brace inserts, designed to accept specific erection and bracing hardware, are placed carefully in their designated locations and secured to the reinforcement. Once the structural embeds, steel reinforcement and inserts have been installed and inspected, workers begin placing concrete. Samples of the concrete mix are taken from the truck and tested by a third party. Beams and cylinders made today will be used to determine the strength of the concrete in a few days prior to lifting the panels. Care is taken when placing the concrete to avoid displacing elements tied into the structural grid. A vibrator is used to ensure complete coverage and consolidation of concrete throughout the panel, especially along edges and tight areas of steel. The topside surface of the panels, normally the interior wall surface, is finished according to the project specifications, and the panels are allowed to cure. As early as the next day, formwork is stripped from the panels and they are prepared for lift day. Workers locate lifting and bracing inserts and prepare them for use. Caps on the inserts, to prevent them from being filled with concrete, are removed. Braces and structural elements are installed on the panels. The job site is kept clean and free of potential trip or slip hazards. Prior to erection, a safety meeting is held. The erection sequence is discussed, familiarity with the lifting and bracing system is covered, and critical safety procedures are reviewed. Each person on the erection crew has a specific role. A safety perimeter related to the movement of the crane and panels is marked off, and all work inside this zone, except for that of the erection crew, is suspended. A third party inspects and certifies a crane, which then moves into position, and work is connected with rigging to the panel. Workers connect lifting clutches to the inserts cast in the panel. Rope tied to releases is kept orderly and will be used to remove the clutches from the panels once they are braced. The cables are pulled taut once all clutches are connected, and one final inspection is made to ensure everything is connected securely. The erection crew takes hold of the braces, and the one person assigned to communicate with the crane operator signals them to raise the panel. The erection crew remains alert and attentive to their surroundings and the movements of the panel. It is critical that their path is completely clear of obstacles. The panel is guided into position and set onto the foundation. Structural shims are used to fine-tune height adjustments to the panel's position. The panel's precise position is monitored via laser positioning equipment and adjusted to meet strict tolerances. The signal person monitors the joint between panels and instructs the crew and crane on the placement of additional shims. Once the panel is in place, workers install temporary braces to hold the panel during construction of the remaining building shell. A variety of systems are available for the lifting and bracing of tilt-up panels. It is important to be sure that all components of the system are compatible long before lift day. Once the braces are securely connected, tension on the lifting cables is relaxed, and workers pull on the ropes connected to the clutch releases to disconnect the rigging. The crane maneuvers to the next position if required, and the process is repeated until all the panels have been erected. A flurry of activity follows as various trades come in to complete their work on the interior and exterior of the structure. The panels remain braced until the engineer of record confirms all permanent structural connections have been made. Once considered a method suitable only for large warehouses, today, tilt-up construction is the method of choice for many developers, designers, and contractors because of its numerous benefits. To learn more about tilt-up construction, visit the Tilt-Up Concrete Association's website and discover the benefits, applications, and versatility of tilt-up construction go far beyond the big box.